Hi friends, the next issue to look at is after sampling. So we got a sample at time t1 and that has got some value, say v1. So we are measuring some voltage and at t1 we had v1. Now the question is, if you want to represent this v1 in terms of a number, then how do you represent? Say if v1 was equal to some pi, where pi is a standard constant we are talking, then it depends on the people's behavior, it depends on the people's requirement, it what the value pi can be. So for someone who is just happy with integers, 3 can be okay, but some others 3.1 may be okay, for others 3.14 may be okay, for someone else if he is not happy with 2 decimal precisions, then 3.142 will be okay, but if it is not happy with 3 decimals, then okay, 3.1415 is there. So that way you can just keep writing 3.1415927 is a standard what do you say, 8-digit form. So the old 8-digit calculators were showing this one, but if you ask for any research person, then even will not be happy, so it will continue like this. And there are some people like the one who is working in space and all that, so for them even value of pi with 3000 decimal places also may not feel precise or accurate. So the question is which one to use. So if I want to talk about v1, then there are so many questions comes out. So definitely everything cannot be used. You can't make everyone happy, you can't satisfy everyone, so there has to be some way. So the way we find out is identify the place where you want to store the information. So when you measure v1, so v1 has to be stored at some place. So if we are working in a digital domain, that's a electronic digital system, then we are working in terms of bits, and in standard we have 8 bits, which is called a byte, and multiples of this are possible. So if you look at this version, then all the memory available is designed in terms of bytes, so it makes sense to work with this information in terms of bytes. So when you say in terms of bytes, then this whole range, whatever you are working with, that should fit in, say, 8 bits. 8 bits means there are 256 combinations, and you can say 0 to 255 is one option, or it can be otherwise, it can be minus 127 to plus 127. So this is a unipolar, that's for bipolar. So sinusoidal of this sort can be represented using this. So the positive peak can be represented with plus 127, negative peak may be represented with minus 127, and so on. So this way, any given point we'll take one of these values. That means this whole thing is divided into 256 levels, and whenever you try to measure the value, just find out in which region it falls, and for every region there is a code, and just use that code as your input value. So that's the way the things are measured and quantized and dumped onto the memory as numbers. So that's a requirement of quantization. Here, the continuous domain, because this we are talking about continuous domain measurement, and any precision you measure, you will not be happy with its accuracy. Therefore, somewhere you have to be satisfied with the limited things. So that's what we convert a continuous magnitude domain into a discontinuous magnitude domain. So here it is converted to continuous to discrete magnitude domain. So that's quantization. Thank you.